Hello and welcome to the MSDP Getting Started tutorial series. My name is Hugh Lobel. I'm the creator and lead developer for the software. And in this first video, we're going to go through the basics of starting a new project, making your first sounds, and the core concepts around signal processing and manipulation in the software. When you open up MSDP, you first arrive at the project loader screen. From here, we can make a new project, resume our last session, or reload something that we were working on before. Today we'll make a new project so we can see how to do everything from scratch. We'll begin by clicking the New Project button, which opens up a Save As window where we can choose where to save our project and what we want to call it. Today I'm going to save on the desktop, and I'll just title this Getting Started. When we start a new project in MSDP, the first thing that we see is a blank pedal board and the system console. All of the audio, video, and data synthesis, manipulation, and performance that we do in the platform occurs on the pedal board, but the system console is where we wrangle all this information together and get control over the various different aspects of the program. Before we start making sound, let's first look at the sound setup on the console. In the top left corner, we can turn the audio engine on and off. We can select our driver, our input, and our output. We can control the volume for the master mix. We can toggle a limiter on and off for the project. And we can see how much of the CPU is being used for our signal processing. One thing that I want to point out is that the CPU meter only displays how much of the program is, how much of the CPU is being controlled by the audio processing. This doesn't display GPU load for video or CPU load for data, so keep that in mind as we work. Before we start making sounds, we should make sure that we have the right driver input and output selected. So we should go through each of these one at a time. I already have my setup, but I'll show you that I'm using the direct sound driver, and my input will be this U440 audio interface that I have from Zoom. Today I'm going to output to my Logitech gaming headset, which might be kind of a funny output, but for performance we might want something like some nice monitors. As we can see, every time that I made a selection from one of those menus, the audio engine very quickly stopped and started again so that all of the signal processing does go out the appropriate channels from here. We can set the volume here. That seems like a pretty good starting point for today, and we'll see very quickly whether that is enough or if that's too loud, or if we need to turn the volume up once you start to work. I'll leave the limiter on as a safeguard, but you do want to experiment with keeping that off so that you can hear the sound as it's sort of naturally unfolding when you're working on your own projects. So now let's make some sounds. In our blank pedal board, we can see in front of us some buttons that allow us to control saving and loading of the pedal board. We also have in the main section of the screen a nice big blank module that we can use to load in whatever process we want to start with. Above that blank module, we have 3 drop-down menus, one for a selection of sound tools, one for a selection of data tools, and one for a selection of video tools. In this first video, we're going to work exclusively with sound, so everything that we do today will occur from the sound menu. Let's start by putting in an instrument. Now, an instrument is a sound synthesis source, and so everything that we make in this will actually be being generated in the program. But if you wanted to start with an audio file, we have a variety of audio file tools. If you wanted to start with an audio input, you can use any of the effects and filters without starting from an instrument. Today, let's start with the additive synthesis. Now, we're actually going to use the newer one, the A+2, because it has some extra nice features. So I've clicked on the A+2, and it loads into that empty module space. This is a pretty involved instrument, but as we can see, we have a keyboard that is laid out across the top of it. And if we wanted to make a note, we could click on one of those with our mouse to hear it now. Now, instruments can be controlled by clicking, as we saw. They can also be controlled by arpeggiators, sequencers, and they can be controlled by hardware. So today for this demonstration, I'm using my Arturia Minilab Mach 2 little MIDI controller. It's sitting in front of me on my desk. And I had this plugged in before I opened up the program, but I don't need to set this anywhere. By default, anything that you have plugged in that is a MIDI keyboard can be used to control any of the instruments. So if I hit a note on that synthesizer now, we can see that we have sound coming from the instrument. So this is just a sine wave right now. It's a very sort of calm but very basic sound. And if we wanted to manipulate this or change it into something a little more interesting, we could use the varieties of menus and potentiometers that we see in front of us. So very quickly, I'll just come in here and I'll select a couple of other waveforms, and then I'll use the volume potentiometers to bring those up. Now, the potentiometers actually are controlled by clicking and dragging in a circular motion, so I'm actually moving my mouse back and forth as if I was turning the dial instead of up and down. And we can actually try that now. I'll play a note and I'll bring the triangle volume up. So also, if you have a specific spot on the potentiometer you know that you want to jump to, instead of clicking and dragging, you can simply click on the location of that value. So if I want the clarinet to be quite a bit louder, I can just click, and immediately the value jumps to that number. That might be too much. Let's find out. So now I'll click and drag to bring that down. Now we have a variety of presets that we can use to get compelling sounds very quickly. So I'll bring up the preset menu by clicking that drop-down button, and under System Presets, I'm going to select Cancellation Pulses. So we can see that some things changed on the interface, and if I play a note now, okay, that's pretty different, right? Now if I wanted to try out some more things, I can go into the different tabs. Here we see we're on the Waveforms tab right now, but I can click on Envelopes to see Amplitude and LFO envelope, and then our LFO tab where we can see the couple of LFOs that are currently being used to create that oscillating sound in the instrument. And these can be controlled and changed in real time too. I could change the depth and the rate on the LFOs. Make them a little bit softer. That's pretty cool. So one thing that I like right now is that the ADSR amplitude envelope is having the note start sort of immediately, and then it decays very gradually over time. Let's make that decay a little bit shorter by bringing the release time down more. And we can see that the note seems to end now as quickly as I stop playing the note. And so now we've tweaked some parameters, and if we like this preset, we can save it now with a new name with our project. So I'll go back to the preset menu, I'll click that down caret, and under the Save Load section, I'll select Save Preset, and I'll give this a new name. I'll call this Cancellation Pulses Better, because I like this better, right? Now if I go to the preset menu, we'll see the system presets from before, but under project presets, we now see Cancellation Pulses Better, and we can load this again with any other A+2 instrument that we use in this project. So now that we have a sound, let's try manipulating it a bit. A pretty common manipulation for instruments is echo, so let's add an echo effect now. So we only have one module so far, but we can see that we have right arrows and down arrows that point off of the module. And if we want to make a new module, we can click on one of those to make a module in that direction. So I'll click on the right arrows, and we get a new module built next to the first one. And now I'll go to the sound menu again, and this time I'm going to select Stereo Echo. The stereo echo is an echo effect where we can get a different echo time for both the left channel and the right channel of your speakers. But by default, we're not going to have anything going through that just yet. If I play our instrument again, we get the original sound, but we don't get it echoed. That's because we need to tell the echo to listen for the instrument. We do this via the input and output addresses. So if we want to hear the instrument, we have to choose an input address, and we can do that from the two drop-down menus. We select a letter and a number. And now we need to have a matching address for one of the two outputs. By default, every module that has an output has the first output set to master out, and this will send the signal to the console and out to your speakers. But the second output is set to master 0. Master 0 is a dummy output, it doesn't go anywhere, and we can override that with something else. So if we want to send this over to the stereo echo, we should select our second output and set that to A1. Now I can just click and select from the menus, or I can use my preferred method. If you set that toggle on, the instrument will now listen for your computer keyboard, and I can type away, and whatever I type will appear in that address. So if I type A in the number 1, and then hit Enter to set that, these two modules are now talking to each other. And if I play a note again, we hear the initial sound, and then at a later time, we hear the echoed sound. Now, the stereo echo is one of the modules, one of the mini modules in the program that synchronize with the master metronome that we can find on the console. In this one, the delay time is determined by the BPM of the project. So if we wanted to, say, make those delays take longer, we could set a slower BPM for the project. Right now we're at 120. Let's try bringing it down to 92. We can click and drag that value to bring it down, or we can click it to select it and then type the number that we want on our computer keyboard. So I've typed in 92, I'll hit Enter to set that, and if I hit a note again, those echoes will take longer. We can hear that longer delay time now. So one of the nice features of the stereo echo is that we have the ability to choose different echo times in our left and our right channel. We can do this via the division and the division number parameters. We can see that both channels by default are set to 4/8 notes as the amount of time between the initial sound and the delayed sound. Let's leave that for the left channel, but we'll choose something slightly shorter for the right channel. Instead of 8th notes, let's try 8th note triplets. And I will do 3 of those. If I play a note now, we'll get our initial sound, then we'll get the right delay, and then we'll get the left delay a little bit later. And we can hear those ping-ponging around now. So that's nice. We've got 2 sound effects, or we've got an instrument and a process. Another common process with instrument creation is reverb, so let's add reverb next. Below the stereo echo, I'm going to make a new module. And we have 3 reverbs that you can use in MSDP. We have a traditional reverb. We also have the Gigaverb, which is an open source reverb algorithm that creates very, very, very long reverb times. Today I'm going to use the impulse response convolution reverb. And I'm going to select Hall number 2 as our sound. Now, like before, by default, nothing is going to this module. We need to tell it what to listen to. Why don't we begin by having it listen to the instrument? Now, the instrument is setting its output to A1, which is being picked up over here, but we can also pick up A1 in any other module. So for our input, I'm going to hit that toggle, and I'm going to type A1. What this means is that the signal is being synthesized, being spit to our master out channel, and then at the same time, it's being spit to both the echo module and to the reverb module. So let's play a note now and hear how that sounds. Okay, very interesting. We're getting that beautiful big reverb happening to the source signal, but we're not getting the reverb affecting the echo module. And that's because we don't have the echo module going to the reverb right now, right? It's going to the master out, and then it's going to the dummy master 0 channel. Now, if we set A1 for an output to the stereo echo, we're going to get a problem because we're going to create a feedback loop where the stereo module goes back into itself. So you may be thinking, well, we've hit a snag here because we can't process both of our signals through the reverb effect. Thankfully, we have a couple of modules in the platform to help with that. I'm going to make our 4th module for today by clicking the down arrow below the synthesizer. And I'm going to go to the sound menu. And to merge signals together, we can either use the signal hub or one of the multi-channel mixers where we mix down to stereo. The signal hub is pretty straightforward, but the 4-channel to stereo gives us some more control. So I'm going to choose that one today. So this is a nice sort of slider-based mixing module. And we can see that we can choose or set the amplitude and change the amplitude for up to 4 signals, and we can choose where the signal goes out. But we need to set up our inputs first. So I'm going to go from the mixer tab to the setup tab, where we can select our input pairs. We can determine whether these input pairs are on, and then we can set the output for each one to be either stereo or to go specifically to the left or right field. Since I'm only mixing together two signals, I'm going to turn the third and fourth input pairs off, don't need them, but I am going to keep both of them as stereo. Now I need to select my input pairs. I'm going to have them be A1 and A2. So that will receive from A1, and we'll set the second output on the echo to A2. If we go back to the mixer now, and I play a note, we can see the signal coming in first to this first input, and then the echo signal going into the second input, and we can control the volume for each individually. Now we have a module where these signals are combined, and I can send them together into the Reverb module. So one last I/O pairing. I'm going to turn the toggle on for both of those, and then I'll type, let's see, it's a Reverb, so I'll choose R. It doesn't matter what you choose as long as you know where they're going. So I'll choose R for Reverb, and then 1, hit Enter, and now everything will be reverberated. So to review this signal chain, we are synthesizing sound in the instrument. That synthesized sound is going directly to the master out, and then it's going to the echo effect. We have A1 there, and it's also going to the first input strip on our 4-channel mixer, which we can see as input pair A1 over there. So it's going in parallel to the mixer and to the echo pedal. Once the signal comes into the echo pedal, it is being echoed at a later time. The echoed sound is going to our master output, but it's also being sent to A2. A2 is being picked up as the second input pair in our mixer, so that both A1 and A2 can be mixed together and then sent to R1. R1 is being picked up by the reverb unit so that we can reverberate all of our sound at the same time. That's a nice sound. Now that we have something that we like, we can save it. I'm going to go up to Save Board, and I have the option to choose the name for this board. I'll call this Big Synth. We get that confirmation that says it has saved, and we can see now our board has the name Big Synth displayed in it, and we can select it from the Select Board File drop-down menu, which means that we can reopen that later should we decide that we don't want it at the moment.